So Yours Wallet is an extension that runs in your web browser that basically every page you visit, it injects a little bit of JavaScript in the page such that there is kind of a tool that the pages themselves can use to interact with Yours Wallet. And Yours Wallet is completely like sandboxed from the website. So none of the code that the website writes can actually dig in and find anything about your keys or do anything with your information. Yours does that, but the websites can kind of build smart requests that say, hey, Yours Wallet, I want you to do X, Y, or Z. And then Yours Wallet will take that request, process it, and pop it up to the user to say, hey, this site wants to do this. Do you want to do it as well? And if so, you can approve it, and then your keys will get pulled in and kind of complete the transaction. So Yours is just a way of kind of keeping your identity, your keys, your money separate from a website. But this whole Yours Provider API does give kind of the language by which a website can speak to Yours to make a request.
Can I just ask, is that at all, like every time you visit a website now, it pops up with, do you accept these cookies? I've heard Ty from Project Babbage touch on this a little bit. Is Yours Wallet an improvement on that sort of relationship where it's actually revealing less to the website than you would normally?
So it kind of, but it's also kind of, so this is the site I pulled up here. It's just a simple little utility site that I've built for uploading files onto the chain.
Huh.
And now to get crazier, this itself is actually, this HTML page and the JavaScript and the CSS are actually on chain as well. So this is an on-chain page that will never change. And it's using ORDFS, which is like this web server thing that I came up with. So when I go to upload.shrugger.cloud, that points to a web server, and then the web server looks up in my DNS and says, hey, what ordinal is the home page for this domain? And then it shows it up. That's kind of a sidetrack, though. Where I was really trying to go here is, so Yours Wallet, the application themselves need to request permission from Yours Wallet before they can see anything about you at all. So at this point, when I visit this page, it knows that I have Yours installed, but it doesn't know who I am. It doesn't know my addresses. It doesn't know anything. This application is then, let me actually open up the code for this. Actually, let's not do it that way. Let's do it this way. Oops. Let's go view page source. So there's, and we don't need to worry about what the details of this is right now, but essentially the code in this page says, hey, is there an object called Yours available on the system? And if there is, I call this like, am I connected to it? And if I'm not, it calls this await provider.connect. And what that does is triggers this thing saying, okay, this page is trying to connect to Yours Wallet. So it asks me as the user, as the Yours user, do you want to let them do that? Do you want to connect and expose your addresses? So again, it's not like keys. It's not like they can spend on your behalf, but there is permission to say, are you okay with me, Yours Wallet, telling this site what your addresses are and what your pub keys are? So I'm going to click connect through. So that is that first level of Yours kind of separating itself from the site. And then when the site asks, can I know who you are? Can I know what your addresses are? Then Yours says, yeah. I mean, then the user says, yeah, and Yours will then expose that information. So that's kind of the first. So yeah, by default, there is, I mean, that's not, nothing there would stop a site from, once you've said yes, writing that data to a cookie, which is then just around in your browser forever. And if you go to other sites from that domain, they can know that the same person who visited here, tied to this address, went to that. But there is, I mean, it's kind of like that the European sites all have the, hey, do you want to use cookies? I mean, there's kind of that aspect of yours basically is the first thing that it puts up that says, hey, do you want, you, the user, want to let this site know who you are?
Cool. What it says OneSat-B. What does the B stand for?
So for uploading files on chain, there's kind of two well-established protocols for doing that. One is one-set ordinals, which is, so a one-set ordinal is a token which says, I'm putting this file on chain and I own this file. And I can then transfer it to someone else or sell it to someone else, or there's an ownership aspect that's being transferred. And in one-set ordinals, that token itself lives on one Satoshi on the chain. So you have an output in your wallet that represents that file. B is older. This goes back to kind of right when BCH and BSV split. And there was the great unfucking of Bitcoin, which the first step was just making it so you could put more data in a transaction. So I think, so there's this concept of an op return, which is basically after an op return in your script, nothing gets executed anymore. It's basically done, but you can throw extra data and metadata and information into your script. So we'll get into scripts later and what that means, but essentially in BTC, it was limited to 80 bytes. I believe in BCH, it might have even been limited to just 40 bytes. And then kind of one of the first things that BSV did to differentiate itself is to raise that limit to 100 kilobytes, which is obviously 1,000 times, more than 1,000 times more than 80 bytes. And so from that point, you could start writing kind of significant data onto the blockchain. And B protocol is something I believe Unwriter came with. Unwriter used to be kind of a pretty prolific dev in the BSV space right after the fork. And essentially, it's very much like one-set ordinals, but there is no ownership aspect. There is no tokenization. It literally is, I am writing a blob of data onto the blockchain. And once that data is written there, anyone can point to it. It's never going to change, but there is no implied ownership. There is no implied transferability. Like, this isn't an owned asset. This is just an asset that exists on chain. And largely for putting websites on chain, it actually makes a ton more sense to use B. It simplifies the network. It isn't, you don't have complexity of, I have a wallet and these are my assets. It doesn't matter whose asset it is. It literally is just, there's a file that is on chain. And then if I go back to the source here. So this web page that I've got running right here, so it doesn't do much. Like, my HTML is very, very simple, mainly because I don't do HTML and I suck at it. And then there's a little bit of JavaScript here as well that is doing kind of the interactions between yours wallet and what's on this page. But you'll see there's other external script files that are loaded in here. And these are other assets on chain. So let me actually just click through to this one. I think I can do this. Yeah. So this file right here, I have uploaded on the chain. Actually, let's go a little further here. So I'm going to take this transaction ID, which is, and let's go to what's on chain. I'm going to look up that transaction. Okay, so this file I uploaded as a one-set ordinal.
Wait, sorry, could you show again where you pulled that transaction ID from?
Yeah, so this is, so this page that I wrote onto the chain.
Okay.
It has references in it to other files that also have been uploaded on chain.
Okay.
So if I'm developing this on my computer, this isn't going to say /content and then a transaction ID and then an output identifier. This would actually say, I don't know, /JS/ this file itself is actually the old Money Button BSV JavaScript library. So this would literally say, I want to load up the file that is /JS/BSV.js or whatever. So this file, when I was developing this, existed on my local computer as a local file. And then so as I was,
you were involved in Money Button, is that right? Or
no, I just it's an open source project. I just took the compiled library and wrote it to the blockchain.
Okay.
So when I was developing it, though, it wasn't on the blockchain. All these were just local files. And so my page is pointing to another local file, which is pointing to another local file, and whatever else. So when I went to go actually put this whole web page on chain, once I got this out there, I can use this tool to say, okay, let me grab, not those. Those are my private keys. Actually, let's open this up. So let me go new one of those. Let's put board sites. Oh, wrong computer. All right, let's do get clone HTTPS.
Is that VS Code?
It is.
Yeah, cool.
So that page that we were just looking at, that started with me developing everything just in this local project. So that first link, when I was first developing it, was actually just pointing to this JavaScript file right here.
Oh, wow.
And so
are BSV and JavaScript are they pretty compatible? Is that safe to say?
Yeah, totally.
Okay.
Really, you can interact with Bitcoin in any language you want. And there are libraries for almost every language. Now, this library right here is actually several versions old. So this is not really supported anymore. But when I first built this site, it was a year and a half ago. There's been new tooling that has been built. Bitcoin Association has built a whole new TypeScript SDK that is not this code we're looking at right here. Well, I don't want to even go too far on that. It is not the code we're looking at right here. I should have said. So a lot of this is like kind of old stuff, but as I was kind of building out the concepts, back then I was using what I was most comfortable with at that point in time. So this example is only so good of an example. It's not really like if I were to start from scratch, here's exactly the tools I would use now, but that's okay. So essentially, skipping over the point about how I got these files onto chain in the first place, now that I have this uploader, if I were to essentially create this site again, let's go back here. So let's go to this inscriber. So when I originally would have developed this, of course, I don't have that file here anymore. So I guess where I'm going here is there's not really good developer tools, but okay, actually right here, this simple CSS. So there is a file in here called simple CSS so this version of the code, it was a work in progress, essentially. So locally, this points to this simple CSS file, which I don't even know where I got this from. I'm not a CSS developer, but it was some sort of just like here's a starting point CSS. And then probably I went in and made a couple little tweaks here or there. But once you stick this file on chain, /simple CSS means look in the same directory that I'm in for a file called simple.css. Well, once I'm on chain, like there is no concept of I'm in a directory and there's a file that's next to my, like once I've uploaded this file on chain, it exists in a transaction ID. And so if I were to kind of build this page and then want to deploy it on chain, I need to take every one of these kind of local files. So let me grab this simple CSS. So I would go choose file here. Let's go source. Board sites. Where did I just clone that? Oh, I didn't put it in. Oops. Move. Sorry. All right. So if I wanted to upload this inscriber file, I need to upload every one of these references, these reference files, and then update my HTML file to point to where those things exist on chain before I can actually test out that it all works and is pointing to the right stuff. So what this little uploader does, it allows me to browse to a file. So here's my simple CSS and simply upload it on the chain.
Cool.
Uh-oh. Did that not do it? Uh-oh. What's wrong with my Yours wallet? Well, that's no fun.
Oh, boy.
This is not an area you'll probably ever need to go into, but I do just want to see where did it break down. Okay, so that transaction did not actually get broadcasted. So I'm going to do something here. Chrome extensions. Oh. I don't think I'm actually running. Actually, no, that's where I want to be. Chrome store. Let me put in. Actually, we're going to do this. I'm just going to build a new local copy of Yours, and hopefully it will have fixed whatever issue is outstanding there.
You're going to build a new Yours wallet right now?
Yeah. Well, so there's the Yours wallet that end users use that are the ones that come from the Chrome store. So those have gone through like a build process and they're all tested and everything else. What I've got installed is I actually pulled the source code down and built it myself. And the Yours wallet I've got installed in here is actually an older version. So now I just built a new one. So the version just updated. So now, what is going on here? It's trying to broadcast a transaction, and that is failing, but it seems to just be doing it every time I open it up. Let's look here. Sorry, this wasn't supposed to be a debug session.
That's all right.
Okay, so I'm going to clear these. Okay, well, we're going to go to a different browser because I don't know what's going on with that one. Actually, let me do this. I'm going to turn this off. I'm going to go to the Chrome store and I'm going to install the actual. Ooh. There we go. Install the actual legitimate one. And then I'm going to close this. I'm going to pin this. I'm going to restore wallet. And let's go. I think. Well, this is going to take a little while, but. Okay. I guess I'll just get to the main point here and we'll try to get that environment set up so I can test this. But essentially, to put files on chain right now, I would have to basically put one at a time. I would load up the CSS file on chain. I would change my my kind of test local one to now point to the location on chain where I uploaded that file. And so, like, it's not like I can just point a website and say, upload this on chain right now. All of these links that are pointing to other local files, each of those files like needs to get written on chain. And then my page needs to point to where they are on chain, not what the local files are. And then once you've kind of gotten all those dependency files uploaded on chain, then it's, okay, let me upload my actual HTML file itself on chain that points to all these other on-chain resources. And so in order to kind of test this out, this file we're looking at has got things in various states. So this first state is basically saying, let me just look at my dependency files in the local directory. Then here, these next ones are actually pointing to an external web server. So if I'm building this locally and I was saying, okay, I want to point to these external references that already exist on chain, it's got to hit like the full domain of some site that is hosting these things, because I'm still just running it locally. So my local machine doesn't know anything about ORDFS, which is how these are being served or whatever. It's just saying, I want this file. So my script, the source that I'm pointing to is https://ordfs.network. So that's saying, go to this other server that exists out on the network and get this file from it. But once I actually put this file on chain itself, I no longer have a local directory, and I no longer really have a concept of, or I should say, I don't really want to have a concept of says point to some domain that exists out on the internet, because the whole point is these are blockchain things, and that ortfs.network may stop existing 5 years in the future. And the page that I've written on chain that's trying to point to ortfs.network, well, that link might be broken at some point in the future. So these ortfs servers, the whole point is it itself is served. So once this page gets on the chain like this, all of these things now are just pointing to /content. So essentially, as far as the web server is concerned, the entire blockchain is your local directory. And how you get to a file that exists out on the blockchain is by saying, okay, look. So this is really telling the server, oops, I didn't want to do that. This is telling the server, okay, in the root directory, go into the content directory and give me a file with this name. Well, the web server doesn't have a content directory. It just gets those requests and says, okay, I see there's a request coming in for a /content link. That means let me go out to kind of the historical set of transactions on the blockchain. Let me find this transaction, the transaction that has this transaction ID, and then output 0. So if I go back, let's go back here one more time. Copy. So I go to that transaction, and then output 0 is a one-sat ordinal. And then so this web server this ortfs server that is serving this all up knows, okay, let me get that transaction, let me parse out what file is in output 0, and let me return that file to the user. So this is that full request. And what's coming back is the actual file that exists in that output. And so then a web page that's just referencing /content/ this transaction, this file exists on chain. Well, that server is going to serve up the appropriate file. It's going to be a valid JavaScript file. It's just going to work like every other browser on every other web page anywhere. It doesn't even know about what's on the server side. So, and then
it has to be, in order to function just like any other web page, it has to be a B file?
A B or a one-set ordinal, either one.
Oh, okay.
Either one of these ways that you can write files on chain.
But you were saying that I thought if it's a one-sat, then it requires like permission to access.
No, not to read. So one-sat, like as far as what's actually on the blockchain. So here, let's go back in here again. So, and this is kind of ugly, I realize, and we kind of got to parse it out. But a one-set ordinal's inscription has 2 fields in it. It has a content type, which is what every file and every web server in the world has. So this is a JavaScript file. If you request a JavaScript file from a web server, it's going to give you this content type header, which says this file is of type application JavaScript. It's just like a type descriptor. And then you'll see in here is the actual JavaScript itself is also just written on chain as a big old blob. So they're in a certain format. That aspect right there of there's a content type and there's a blob of data, that's the exact same between B and between one-set ordinals. The real difference is this sits on 1 Satoshi, which means this is a UTXO. This is an asset in the chain that is owned by someone. And at the very, very end of this thing, which actually this cuts off, there's other logic than just this inscription. Actually, no, it's this part right here, I think. Let's go script. Yeah. So This part right here is basically data that says someone. This is the hash of the public key that owns this, and if a signature comes through for that pub key, that person can transfer this asset. Where the B stuff, this is a 0 Satoshi file, and there is no locking script. There is nothing that anyone can ever do to spend that output. That output is essentially just kind of fingerprinted into the chain, and that's it. There's no money tied to it. There's nothing you can spend. So from a writing side, nothing really changes. You're just writing a file on chain. But with one-side ordinals, there's this implied tokenness that I could transfer this to someone else, and now they own the token that represents this file. Where for just on-chain coding, you don't really need any of that concept of here's a token, here's this thing that I can own and I can transfer or whatever. I can just point to any file on the chain. In fact, let's just try.
That Bitwarden, is that a BSV
Password
specific?
No, it's an open source. It's like a 1Password or anything else.
Okay.
Okay, so I've got crap tons of these already. All right, here's one called B. Boom. Okay. So let's just go and test this one.
This is like a pub key library, or?
No, this is Jungle Bus.
Oh, okay.
Jungle Bus is basically an index of various, like, kind of what protocols happen in what transactions and things like that. So I'm just trying to get an example of a B transaction. So I don't even know where those started. Let's start at block 600,000. And some of this stuff, okay. Hopefully this isn't anything too risque. Let's go to... Okay. So this transaction is a B. It's Bitcoin B output. So you'll see it starts with 0 op return. That essentially is saying this 0 is a false. Essentially, it's saying the unlocking script for this is a false statement, and then the script is done, which means there is nothing you can do to make this evaluate to a true value, which is kind of how, and we'll get into that more later, but like scripts have to end in like, they have to execute code that leaves a true value at the end of your stack, which again, I don't want to get too far into that. These false op returns are a way of saying there is not anything you can do that can put a true at the end of the stack because we put a false at the, like we intentionally, there's a false there and then we're returning. So this is an unspendable output. And there's no Satoshis on it, so no money is getting locked up on the chain or anything like that. It's literally just saying, I'm writing this to the chain, and that's it. There's nothing else that can ever be done with that output. It just exists on the chain.
Where does it exist on the chain?
So in this transaction right here. So someone wrote this transaction to the chain. This was the money they paid to make the transaction. So these are the inputs. So I guess we can take a step back even of just kind of core aspect of Bitcoin. So coins are initially created by miners building new blocks. And that's kind of outside of the scope of any of this. But at some point, miners build new blocks, coins come into existence, and they exist as an output of a transaction. And so then every new transaction spends as inputs outputs that existed somewhere else previously on the chain. So these things.
Can I just ask a detail there? Every output contains 2 unspent transaction outputs. Is that right?
No.
No. Okay, never mind. Sorry.
No, it's just there's lots of things that get confusing by how things traditionally have been done, or like there's just, but no, I mean, every time there's a block that gets created, the block reward is essentially a single output. In fact, let's go open up another chain on what's on tab right here, or what's on chain, and let's find any random block. This first transaction that exists in a block. Let's go into it. So the input here is not really an input. These are newly minted coins. The network created 3.125 coins when this block was mined. And they are transferred to one output. So whoever this address is, right, this is the address of the miner who mined this block. So they have those 3.125 Bitcoins plus the transaction fees from all the transactions that happened into that block. All of those fees now live in this one output right here. And so, and there's some other things about how long it takes for those to mature or whatever. We don't need to get into any of that. So essentially, this one output has 3.126 blah, blah, blah Bitcoin in it. So when we're building a transaction, inputs from other previous transactions, like there needs to be value. Every transaction needs some amount of value in it to pay for transaction fees, for instance. So except for these block rewards that are special case, every transaction needs one input in it. It needs some money coming into the transaction, because how you pay transaction fees. Oops. Let me just turn my phone silent. How you pay transaction fees. So these are input, the amount of BSV coming into a transaction. This is the amount of BSV going out of the transaction. There's always going to be a difference between those numbers. You always need to leave some of the inputs unallocated to pay for a transaction fee. So like there is 68434 BSV coming in and 67700 going out. So you'll see the difference here. The fee that was paid is 738 Satoshis. So that's simply the difference between the inputs that came into the transaction and the outputs that come out of the transaction. And so that's left as kind of the incentive for miners to include your transaction in their block. And when they do that, that's how we have this difference between the 3.125 and the 3.126, blah, 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 blah. Like this amount is what was unallocated in all the transactions that are included in this block. And that miner gets that. That's their fee for mining. So in this transaction right here, they paid these two inputs. One of the outputs is just this file, whatever this file happens to be. It looks like it's, I don't even know what it is. It's some sort of a meta protocol thing of some sort.
It's got some money button code in there or something.
Yeah.
Okay.
Again, this is literally some sort of file. It's a JSON file.
Okay.
But what it is or what it represents, or I have no idea why anyone wanted to put that there. It's just a file on the chain, and it's of type application JSON. So then the second these second two outputs right here are essentially payments. So in the same transaction, I'm paying someone else some of the Bitcoin that so I control the inputs. I've added this many Satoshis to the inputs. I'm allocating the outputs. So I'm allocating these to two different addresses. Those are often going to be one of two cases. Either one, I'm paying someone in this transaction, or number two, these numbers don't add up to, like, I got to get my change back. I'm not just going to spend this entire amount into transaction fees, because anything I don't allocate in an output becomes transaction fees. So if I go to the store and I buy a pack of gum for $0.25 and all I have is $1, the store needs to give me 75 cents back. I don't think you can buy packs of gum for 25 cents anymore, but hey. Used to be able to when I was a kid.
Right, yeah.
So essentially, your outputs will either be, this is money I'm transferring to someone else, or this is money I'm sending back to myself as my change. Because when you spend a UTXO, you spend it in its entirety. It could have 50,000 Bitcoins in it, or it could have 1/50,000th of a Bitcoin. Whatever it is, that whole amount, that UTXO is... So UTXO is unspent transaction output. Well, as soon as you put it on the input of a transaction, it's now a spent transaction output. And so your change is going to come back as one of these outputs, is the change coming back to the user.
And is that a UTXO, what comes back to you?
Yeah, so these are both, well, at the time that you make them, yes. Now, this one right here, we can see from what's on chain, has actually already been spent in another transaction. So you can kind of like click through and model the whole, where was all this spent and what was it all. But for the concept of we're creating a brand new transaction, yes. Every one of these are unspent transaction outputs. Now, this one right here is an unspendable transaction output. There's no value in it. There's no locking script in it. You can't actually spend it, but it doesn't have any value in it. So the nodes, the miners aren't actually keeping this around as like, oh, this is a UTXO. This false op return is it's a known case for the miners that says, if I see one of these, this is not spendable. I don't need to keep this around in the UTXO set. It's an unspendable. It's just recording data on the chain. So let's actually find a better example that might be an image here. JSON. Let's actually go back. Let me just do this in another tab. So B. So I'm also going to add a context here of image/JPEG. And then let's start it again. Okay, and this one's an image JPEG. So let's go back to what's on chain. Let's look up this transaction. Okay, so you see this is now not JSON. This is just some binary gobbledygook.
Which you just put there, or?
I just found one that already exists. This is from block 600,005, and we're at like, I don't know, 860,000, some 877,000, whatever, right now. So this is years ago, this transaction. But if I go to, so that was at output, that was at output 0. So if I go to ordfs.network/content/that_0. Okay. So some dude uploaded this picture of himself on chain. I don't know who he is. I don't know why he did it, whatever. But just by pointing at that transaction ID and that output. Sorry, my dogs. Let me close the door for a sec.
That's fine. I do not know that person.
Yeah, I don't know this person either. But we can find, literally all these things exist on chain somewhere. I can grab any one of them and okay. memes, whatever else. Like these are just things that people wrote to the chain years ago when they were playing with the chain. But I can then in my whatever pages I'm writing on chain, I can reference /content/ that file, and that file will be a link on my web page, or will be pulled in through my web browser.
That's cool.
Yeah.
Can I ask one question about something you touched on earlier on what's on chain?
Yeah.
So it was just on this page right here. I'm going to try to point, but in the output section, it was data that was being written to a Satoshi, and there was a series of op codes. There was op return, op.
Yeah. Well, let's start here. Well, go ahead and get to your question. Sorry.
My question is, whatever that string was before the public key, or however that was constructed around the public key, I have had this question for a while, which is that is one Satoshi, or is what gets written on chain on a Satoshi, is it pretty much like from a security standpoint, like pretty much totally secure? You need somebody, if that Satoshi is going to reveal its data, you need whoever has that public key to sign it?
No.
So I guess let's
this is it. Yeah.
Let's kind of talk about scripts in general right now.
Okay.
So I talked about the fact that in order to create a transaction, you have to spend an existing out point, an existing UTXO.
Mm-hmm.
How you spend those. So what we're looking at right here is this is the assembly representation of Bitcoin script. So this output right here has a locking script. And when you go to spend it, let me actually go to a different view here, scripts. So this transaction, it has its own output. That's the new UTXO that's being created. But the input is spending a UTXO from another transaction. Actually, let me go this way. So in this transaction, you have to put together both the locking script of the UTXO you are spending with an unlocking script that allows you to spend it. And those two bits of logic are kind of executed together. And when those things complete execution, they leave, I don't want to get too complicated in the stack, but essentially if they result in a true statement, that input can be spent in this transaction. And what you do with it is kind of completely up to whoever's like, I don't want to say this better. So this JSON we're looking at here is just an alternative representation of what we're looking at right here. So when this is spending this C49C output 0, that output had this script. Just this script. So it's basically saying when you pass data into the input, which is this part right here, the script sig, and this is called script pub key. Those get confusing names, but essentially those two things get run together. And if this is essentially kind of like if you're calling a function in a programming language, this is like your parameters. These input values are like your parameters that says, okay, so let's say I've got a function that says, is even. So you pass a number into it. If you pass in 17, it's going to return false because it's not even. Where if you pass in 16, it's going to return true because it is even. So this is kind of that. So what we're looking at right here is the most common locking script that exists anywhere. And this is what's called a pay to public key hash. And what pay to public key hash is, and this is probably more detailed than you need to care about right now, but I think it's important for the background. So essentially, these two values right here, this 304 blah, 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 and this 0267C, those two blobs of data are our parameters, are our 16 or 17 in the is even function. And what it's trying to solve is it's basically saying, well, there's kind of two different things here. So this second value that's being passed in is a public key. So when whoever wrote this other transaction in here, they basically said, okay, I'm going to duplicate this public key. I'm going to run it through a different hash called a hash 160. And then I've got this value, this public key hash that I wrote to this output when I wrote the output out there. So I'm basically saying, okay, whatever pub key you pass in, if when hashed via hash 160, it equals this value right here. So this op equal verify basically says, if when I hash 160 this pub key, it needs to equal this hash right here. So this op equal verify is either saying either these two things are equal to each other or we're done. This did not work. So you did not pass in the right pub key to spend this transaction. And so using this pub key hash is like it's like a way of fingerprinting that I'm saying, I'm not writing out to the world what is the public key that can spend this. That's out, like no one know when I say, okay, there's this output that has that much BSV in it. Whoever has the pub key that hashes to this value can spend it.
So it's like a pub key protected by a hash?
Yes, exactly. That's
Okay.
exactly what it is. Now, as soon as someone spends it, they reveal their pub key. So once it's being spent, that correlation between that pub key and that hash are now public. People have seen what this pub key is in order to hash it to get to this thing. But when you just sent someone money, no one knows on the chain what public key can spend that. You have to have the public key to hash it to that value. I'm probably getting confusing. And then the next part here is basically saying this first big blob is a signature of the transaction. So that's saying this public key has applied a cryptographic signature to the transaction. And there's rules for what you hash together to count for signing the transaction. That's way too complicated for now. But essentially, it takes the transaction itself, hashes it, and then applies a cryptographic signature to it. So this check sig right here is basically saying, okay, I've got my pub key. I've got this signature. Is this signature valid for this transaction that I'm in? So that's really when you can unlock a pay to public key hash, UTXO. That's what this script is called, pay to public key hash.
And that signature is a private key just like any other, or can it be?
Well, it's a signature. So it's used. It used the private key associated with this pub key. And it used the hashing mechanisms just built into Bitcoin for how you hash a transaction. And so it's a signature from the private key associated with this pub key against the transaction I'm spending in right now. And that's how kind of the script engine in Bitcoin basically says, okay, you are the person who can unlock this and you provided a valid signature, you can spend this. And so this check sig is going to leave a true on the top of our state. And that's the last thing on the state. And so therefore the miners are going to allow that input to be spent, or allow that output to be spent as an input, I guess I should say. So you can write literally any logic you want in these output scripts. So in this transaction right here, 1 Satoshi is protected by a script that has, at the beginning of it, you'll notice this exact same pay to public key hash script.
Yeah.
So the same rules for spending this apply to the other one we were just looking at. But there's some other little magic that's going on in this script. So this op false op if is basically and then down at the way bottom, there'll be an op end if. So essentially this is like, if you're writing code in Python or JavaScript or whatever, and you have an if statement that says if false, that code will never, ever, ever get executed because false is never true. But there's an opportunity to just kind of stick other data in between that false if and the end if that's at the very, very bottom.
Huh.
So that's kind of an ordinals stylistic, like on BTC when they were creating the original ordinals, they don't have all the opcodes we have in BSV. So it's like they had to get very, like, this is a way that I can stick data into a transaction that isn't going to do anything. It isn't going to affect whether or not this script executes or not. This is a no op. This is a no. It's basically a comment. It's like a comment in your code that it's like, this isn't going to do anything, but I can put other information in there. There's other different envelopes, different payloads, ways where you can do the same kind of thing, where you can stick a blob of data into a transaction. In fact, if I go back to this one, op return is another approach to that same thing. That basically says, when this script is being executed, I run to this point and then I return. So there's no more execution on this script after this return. So nothing else can affect the truthiness or falsiness of this transaction. I'm done processing it. But I can stick a blob of data that isn't going to get processed. I can stick that in there because that's how you get things on chain. Like essentially where you're writing data onto the chain is you are creating outputs. And for something to kind of exist on the chain, it either needs to come that you write a transaction with that data as an output, or one more thing, or you need to pass it in as an input to unlock a previous output.
Okay, I need to wrap it up.
Yep.
Sorry, but
no, that's cool.
I just have to do something real quick, but then I'll be right back.
Yeah, I'm gonna actually close up our recording and we'll talk again after.
Okay, thanks.